Hello everyone, today we're going to talk about imaginary roots. Now, what is an imaginary root? Now before, when we broke down radicals, we started, 24 is, you can do it any way you want, so let's say 2 and 12. Well, 2's all done. Then you break down 12 as 2 and 6. Then we broke down 6 as 2 and 3. Okay, so we put that under the radical. So 2 times 2 times 2 times 3. And again, since the index of the radical doesn't show, it's automatically a 2. Kick out our perfect pair. So we're going to have 2 radical, then 2 times 3 is 6. Now, when it comes to imaginary, the first thing I have to deal with is this negative. The negative immediately kicks out as with an I. Okay, and we'll talk about what that means in a minute. So I radical 24. Okay, so then from there, we just do what we did before. 2 and 12, 2 and 6, 2 and 3. So I radical 2 times 2 times 2 times 3. Then we circle our set, kick that out, so you have 2I radical 6. So the difference between a regular one and an imaginary is, again, dealing with the negative under the radical. Alright, so let's talk about what I means and where the values come from. I is really just I to the first power, or I, which is equivalent to radical negative 1. Okay? So when we think about it, when you have a negative 1 under the radical, it's going to come out as the perfect square of I, and really I is just what we call I to the first power. Okay, I squared, okay, if I break this down as negative 1 times radical negative 1, now if I multiply these together, I get radical negative 1 times negative 1, which then creates a perfect grouping, so it kicks out as negative 1. So I squared is really equivalent to negative 1. I cubed, okay. This just means now that we're going to have 3 negative 1s under the radical. Okay. Now again, pulling my perfect groups. So I'm going to have negative 1, radical negative 1, or negative 1I, because this is really just I, remember? Or, as we just mathematicians put it, it's just negative I. Now I to the fourth, okay, is again 4 of these things. So negative 1 times negative 1 times negative 1 times negative 1. Again, circle your pairs and kick them out. So that's negative 1 that comes out. Then I got another set that kicks out as negative 1. Now no more radical. So negative 1 times negative 1 is positive 1. Now, we now know that I to the fourth is really negative 1. But if we also think of it, I to the 0 also represents 1. Now the reason that is because the i's will cycle in a factor of 4. So now, in this example, we're going to ask you to evaluate what is I to the 35th in terms of these guys right here. Okay? So first thing I'm going to do, I'm going to teach you a little trick. Okay, so what we're going to do is we are going to take the exponent of I and divide it by 4. Now what this is going to do for us is it's going to give us some number, blah, 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 and a decimal point. Okay. So what we're going to do, we don't want this. We're interested in the decimal, so we take that decimal and then times it by 4, and it gives us our new exponent of I. Okay. Now you might be sitting there wondering, well, what's the big deal? Okay. Well, it is kind of a big deal. Okay, so I'm going to kind of, whoops. No, it looks like I'm not moving that, huh? Okay, we try it again. Okay. So, alright, so now what am I trying to get at here? So what we're going to do is we're going to take this, take 35 and divide it by 4. Okay, so when I take 35 divided by 4, you get 8 point, that's going to be 32, and again you could probably do this on your calculator, 8.75. Okay, now again I'm not interested in the decimal, in the regular number. I want this guy. So we're going to take 0.75 and then times by 4, and you get 3. So what's the importance of this? Well, I to the 35th power is really equivalent to I cubed. Now, based on our chart, I can look at this and figure out, well, what does it really mean? Well, I cubed, as I can see, is equivalent to negative I. So that's what I'm finally looking for. We don't want exponents when we're dealing with I. We just want to keep it as simple as possible. Alright, I to the 1/2. Okay, so again, we're going to use our little trick. So I'm going to take 102 and divide it by 4. Now again, if you've got a calculator, this is going to be easy. However, I do not have a calculator right now, so I'm going to have to do this the long way. 4, that's going to be 2, that's going to be 8, that's 22. It's going to be a 5, which is a 20, leaving a 2. Okay, so this means you're going to have 25.5 if you did this on a calculator, which is probably the better way to do this. Okay, so now get rid of this. I don't need that. I'm only interested in the decimal. Let's take 0.5 times it by 4, and we get 2. Okay, so this is my new evaluation of I. So this is I squared. So now let's evaluate based on these guys over here. And I squared is really negative 1. So that's what that is. Alright, here let's really have some fun. Alright, 1978 divided by 4. Now again, if you got a calculator, that's awesome. I do not have one with me, so I'm going to have to do this a long way. Divide by 4. Get a 4, 16, that's a 37, that's 9, which is 36, 1, 8, that's going to be a 4, which is 16, which is a remainder of 2. So this is going to be 494.5 if you did it on the calculator. Now again, I don't want that. That doesn't interest me. I want this. So we're going to take 0.5 and times it by 4, and we get 2. Alright, so this is equivalent to I squared. And again, based on my chart, this is equivalent to negative 1. Alright, pretty easy. Alright, so I'm going to let you try this one on your own. I'll give you about 30 seconds or so. So again, just leave the tape running. And again, I will catch up with you in a second. Alright, folks. Now hopefully you got this done. Because if you got a calculator, this doesn't take very long. But unfortunately for me, I don't have one right now. So I got to do this the long way. 1, 5. Bear with me. That's a 5. That's a 20. 1. That's going to be a 0. And that's going to be a 3, which is a 12. Remainder 3. Okay. So it's going to be 503.75. Okay, so again, I don't want that. I just want this. So So 0.75 times 4, we get 3. Okay? So this is going to be I to the third power, which based on these guys over here is really negative I. Alright, so let's work with this now. So again, like I showed you in the lead-off examples, first thing we're going to do, anytime I'm dealing with a negative under the square root, I'm going to immediately kick that out as I. Okay, don't even mess with it. Don't even take time to think about it. Negatives immediately get thrown out as I. Okay? Now, let's break down 12. Just like we normally did. 2 and 6, 2 and 3. So, let's put this back together. We have I radical 2 times 3. Okay, so again, I got a perfect pair right here, so I'm going to kick that out. And again, that's going to times with the I. Okay, so 2 times I is just 2I. Radical, and then all that's left under the radical is 3. So there it is. Okay. Alright, so get another one. Okay, so now the negative kicks out as I right off the bat. I don't change anything, I don't fight anything, it's just automatically I. So let's break down 49 for ourselves. 49 is 7 and 7, and that's as far as it goes. So I radical 7 times 7. Perfect pair right there. That's going to come out. Multiply with the I. Now again, remember, I took everything out of the radical, which means there's no radical left. So let's multiply this. 7 times I is 7I. There it is. Piece of cake. Alright, I'll let you try this one on your own. I'll give you about 30 seconds or so. Okay, this shouldn't be too difficult. So again, just leave the tape running, and I'll come back in a second and we'll talk about it. Alright, so let's talk about this. Again, first thing I see and needs to come out, the negative. Out it comes, and it comes out as I. Alright, now let's break down 40. Well, 1 times 1 is 40. You can hear my students already going, it's 2 and 20. We always stick with the 2s. 2 and 10. 2 and 5. Like so. Okay, so I, radical, I've got 3 2s and a 5. Alright, let's get our perfect groups. I got a set of 2s that can come out. So 2. Alright, so let's multiply these together on the outside. I get 2I radical. Now, I've got 2 times 5 left under the radical, so that gives me 10. And there it is. Piece of cake. Alright, give this one a whirl. Alright, again, I'm going to step away and let you try this one on your own. Again, leave the tape running. I'll give you about 30 seconds or so to work on this, and then I'll come back and talk about it. Alright. Alright, so here we go. First thing I see, negative, comes out as I. Okay, so now let's break down 500. Now I'm going to do this a little faster because divided by 2 will take me all day. So there's 5. 100 I know is 10 and 10. 2 and 5. 2 and 5. Okay, so let's reset the radical. We have I radical 1, 2. We got 2 2s, and I got 3 5s. All right. Now let's break out our groups. Set of 2s will come out. I also got a set of 5s. Okay. So we'll multiply this all together. So 2 times 5 is 10I radical. Now all that's left inside the radical is the 5. And there it is. Alright, I'm going to work this one with you because frankly this won't take too long. Because again, the negative, I'm immediately going to kick out its I. Now when I break down 13, 1 and 13, that's it. So it's not going to do much for us. So our final answer is just that. Pretty easy. Alright, how to add and subtract complex number. A complex number is a number with a real and imaginary component written in this format, a plus bi. So like 4 plus 6i, or you can have 2 minus 2i, stuff like that. That would be examples where we have the real component. And then we have, with the I piece, we have the imaginary component. Alright, so how to add and subtract. Okay. So how to work with this one. Again, I'm going to kind of take you back a little ways, so just bear with me. Whoa. So, remember when we used to do stuff like this? Okay. We have the plus between. So what we would do is just combine our like terms, right? So 6 plus 2 is 8. 5x minus 3x was positive 2x, and we would be done. Right? That was easy back then. Well, now we're going to do it just like we did before, but instead of x's in this one, we have i's. Okay? So here we go. 6 plus 2 is 8. 5i minus 3i is positive 2i. And we're done. Same thing. Nothing's really changed except instead of variables, we're dealing with an imaginary component. That's all. Alright, so let's look at this one. Okay, so first thing I notice is a plus. So we're just going to combine our like terms. So negative 3 plus 4 is 1. Negative 2i minus 3i is negative 5i. Done. Nothing more else to do there. That's it. Alright, let's do another one together. So again, adding, so 5i minus 5i completely cancels. Then we go negative 6i plus 2i is negative 4i. That's it. Done. Nothing else to do. Nothing, it doesn't get crazier than that with it addition, subtraction. Alright, so now how to handle subtraction? Now again, remember that back in the day, when we dealt with subtraction, remember we did this. We changed this to plus. Oh, that looks awful. Let me fix that. That looks terrible. Okay, we changed that to plus. Okay? And then when we did that, we changed all the sign. This becomes negative 8. This now becomes a positive 3x. And then we just added our like terms again. So 4 minus 8 was negative 4. 4x plus 3x is 7x. And we were done. Okay? Now again, just like before, we're going to do the same thing we did over here. So first thing I'm going to do is change this over to plus. Try that again. Change that over to plus. And just make a mess, okay? This becomes negative 8, and that becomes positive 3. Alright, so let's put this together. Negative 4 minus 8 is negative 4. 4i plus 3i is 7i. And we're done. Again, the only difference, like I said before, instead of x's, we're dealing with i's. Nothing major, huge difference. Alright, so I'm going to let you try this one on your own. I'll give you about 15 seconds or so. So Again, we'll just leave the tape running, and actually by the time I stop talking, we should be ready to talk about this one, huh? Because this isn't too crazy. Alright. So here we go. Let's talk. I changed the thickness of my pen, so there we go. Not a plus. This goes to negative. This also goes to negative. Okay? Now just combine our like terms. So negative 2 minus 3 is negative 5. 5i minus 2i is positive 3i. And that's it. Done. Alright, let's try this next one. I'll let you give it a whirl to see how you do. Then go from there. Alright. So, again, change to plus. Change that to plus. Change this to minus. Now let's combine like terms. So 4 plus 2 is 6. Negative 3i minus 6i is negative 9i. Done. Alright, I'll step away for a few seconds. I'll let you try this one. This one, again, just like before, nothing crazy. It's pretty simple. Just do what you need to do. So I'll give you a few seconds to work on this one. Alright, so first thing, let's change that to plus, negative, and negative. Okay, so here we go. 5 minus 6 is negative 1. 3i minus 6i is negative 3i. Done. Alright, one more. So again, I'll give you a few seconds. I'll let you try this one out. We'll see how you do. And then from there, come in and take care of business. Alright, so here we go. Change it to plus, minus, and minus. Okay, so here we go. Negative 4 minus 8 is negative 12. 9i minus 8i is plus I. There you go. Alright, so this is the end of the part 1 of these imaginary roots. Again, make sure you check out the second part that deals with multiply and divide and all that other fun stuff. So I will catch you later.